Hey everybody, it's Mr. Mott. We're going to go through the analysis of the data we collected in the video that you guys may have watched. This is experiment 4 for AP Chem, determination of a chemical formula. The idea behind this lab is that we have this hydrate, and we know that the generic formula is CuX, Cly, H2OZ. With X, Y, and Z being unknowns, but we know that they represent numbers, and those numbers represent moles. And so what we ultimately want to figure out is the mole ratio of X to Y to Z. And so in our process in our lab, we went through different processes where we tried to figure out how much copper, how much chloride, and how much water we had directly and indirectly. So let's get started. So I've got my data table here with my masses, and what we're going to do is go through the process of what we did and what it tells us. So the first two things, we got our mass of our crucible, and then we got our hydrate, and we start out with 1 gram of it. Then we heated it up, and we removed the water from it. So the difference between the mass of the crucible plus the hydrate and the anhydrate is the mass of our water. So what we're going to do is subtract them, 11.66 grams minus 11.48 grams, and that's going to give us the mass of the water. So we remove the water, and by removing it, we determined how much water was actually present, which was 0.18 grams. Okay. After that, we took our anhydrate, we added water to it. Sounds counterintuitive, but we dissolved it so that then what we could do is get the copper ions out of solution. We got the copper out of solution by putting some aluminum in it. We got the copper by itself by filtering it, and then we ultimately isolated the copper. And so we can take our mass, the difference between the mass of the watch glass plus the copper minus the watch glass, and that's going to give us the mass of the copper. And so I can take 29.03 grams, and we're going to subtract it from 28.67 grams, and let's see what we get. 29.03 minus 28.67, 0.36 grams of copper. Now, we figured out our grams, and ultimately, always a bell, ultimately we can figure out the moles, but let's first figure out our grams of chloride. So we know the grams total of our hydrate was 11.66 grams, which was the mass of the crucible plus the hydrate minus the mass of the crucible. So we know we started out with 1 gram of our hydrate. So if we take our 1 gram of our hydrate and we subtract the water and we subtract the copper, that's going to tell us our grams of the chloride that we had. So 1 minus 0.36 minus 0.18, we get 0.46 grams of our chloride. So now what we're going to do is we're going to take our masses that we have and convert them to moles, and then look for a mole ratio. So if I take my 0.18 grams of water and I want to convert it into moles of water, my molar mass of water is about 18.02 grams for every 1 mole. So 0.18 divided by 18.02. Let's see, with maybe 2 sig figs, I'm looking at 0.010 moles of water. We're going to do the same thing for our copper and our chloride. Okay, convert it into moles. And for my molar mass of copper, 63.55 grams of copper for every 1 mole. So 0.36 divided by 63.55. The 2 sig figs, we're going to get 0.055 0057 moles of copper. Next, what we're going to do is do the same thing for our chlorine. We had 0.46 grams of chlorine, or Cl, I should say. Yeah, either way. And then we're going to divide this by the molar mass of 35.45 grams for every 1 mole. And then that's going to be equal to 0.013 moles of Cl. All right. And now what we're going to do is we're going to take our smallest number of moles, which is our copper, put that on the bottom, 0.0057 moles of copper, and we're going to compare that to our moles of water. And what that's going to tell us is for every 1 mole of copper, how many moles of water do we have? So 0.01 divided by 0.0057 gives us about 1.75 moles of H2O. And then similarly, what we're going to do is take our 0.0057. Again, we're choosing that because it's the smallest number of moles, and divide it by 0.013 moles of Cl. So 0.013 divided by 0.0057 gives us around 2.3 moles of Cl for every 1 mole of copper. Now, so what that tells us is that if we were to take these numbers, generally these numbers here, they ought to be whole numbers, but experiments don't go always as planned. So typically, what you would round them, but these would really tell us the mole ratio and the formula of our hydrate. So if I wrote it and I just used these numbers here, I would say Cu1. And then for my Cl, it would be 2.3. And then for my water, it would be H2O 1.75. Now, we can't have decimals or fractions there. So typically what you would do is that you would round this. And so I would have the Cu is going to still be 1. My Cl, I would probably round to 2. And my H2O, I would probably also round to 2. And this is actually the formula of the hydrate that I chose. And so our numbers come pretty close to it, but overall, that's the process. So thanks for watching. Hope this was helpful.